Today's Leetcode problem 199, binary tree right side view. Okay, this is easy. Uh, okay, so given a root of binary tree, imagine yourself standing at right side of the return the values of nodes. You can see order from top to bottom. So what this question basically means is this is the tree and you're standing somewhere here. So you can only see the right side of the tree, right? This, and this. Now, there are a lot of edge cases in this question. As per I know, uh, let's draw a few things. Okay, uh, let me show you. So this is a tree, yeah, and you're standing here. Yeah. You're standing here. Now you are looking at this tree. What do you think is the right side? This whole tree is the right side. Now again, let's go deep. Let's say now this is the tree. Now what is the right side? You might think this, yes, and this, because you can see the root node always, because it's the only node, and then this, and because this node is behind this node, you cannot see this. Let's say you now have this node. Now you can see these three nodes, and you have this left node. Let's say you have here two nodes. Now you can still only see this node, right? And let's say you have this node here and this node here. So now what do you think is the right answer? This is the right answer, yeah, but again, there is one more node on this side, and you also see that. Let's say you have another node here, right? Now what is the right side view? Right side view is this, and this. So the problem with this question, this tree question is that we assume that we have to go only to the right side and check if node is present. And if you do that, that's the problem, right? So what you do is you go this side, and you think, okay, this is I see, I add it, then I see this, I add it. If it has right, I go to the right. If not, then I go to the left. And this, yeah, so you add this, and now there is no more left right. So most of the time, at least when I did this question first time, I did that I missed that cases. So that's not gonna work because these nodes are still, you can see them because they are not on the right side of the tree, but they are the rightmost at rightmost side from their point of view, from your point of view, right? So the you what you can do is, let's say you go level by level. So you have this level, you have it in your some list or something, and you pick the last one. Okay, so you have this node now. There was only one, so you pick this one. You add this level to the temporary array and you choose the last one. Okay, so now it makes sense, right? It is, you can have this. Again, you add all the next level and you have the last node, that is this one. So you have that in answer. Again, still the tree is not empty, so you add next level and the last node is this in that level, temporary level. Again, you add this level and then the last node in that level is this node. So you get the idea, right? So what you have to do is we have to go level by level, like breadth first search, and pick the last node in that. So mostly I write a few things that I'm going to write now. Um, I actually write them before or sometimes with after the algorithm. So what is the input? Input is just a root node, right? A root node of the tree. Output is right side values. Now this is very important because sometimes if I don't write this, I might return the right side nodes. So I write it, and it at least it might catch some bugs. Then what I do is size. I discuss size with the interviewer. So I start at the minimum. Do you think um, the root can be null, or that is the root? The tree is empty. The size of tree is zero. If I ask this kind of question to the interviewer, and if he says yeah, it can be, so you have to catch that case, right? If not root, return root, or whatever they ask you. But in this case, the numbers, the number of nodes in the tree can be from 0 to, yeah. So it can be empty. So we have to return empty list in this case. Yeah, here you can see that. Then maximum size uh, for tree questions, I don't think it matters. But uh, if you ask it, interviewers say don't. Let's assume it's valid size. It's taken care of or something like that. And I also discuss the values sometimes. So uh, here it's just a tree, but if you see binary search tree, right? In that case, you don't allow some duplicates or negative values or something like that. That can be a case sometimes. So just ask. So here we have integer values. So uh, I assume there are positive, negative, zero, and duplicates. All kind of values allowed. So this constraint doesn't say that, but yeah, it's good to assume that negative values will be there, and up to 100, that's fine. Okay. And to be like to not miss few things, I write some checklist like edge, test cases, algo design that we did. Algo design is like going level by level. Code that I will do, time and space. So most of the time after writing code, you can write the time, space and time complexity. But as I know that I have designed the algorithm, right, and I'm going to go through each node only once. So I think the time complexity is 1 of n, and uh, space complexity is going to be O of 1. Uh, I'm saying that because I'm not going to even use the temporary array to have all nodes. What I'm going to do is I'm going to only have one previous value, and when I'm going through level, right, I'm just updating that previous value. And once the level is finished, I'm going to write that previous value into the return list. So in if we have like uh, you can ask this to interviewer, right? That uh, is output uh, considered as do you want to think that as a space utilized, or you want me to write space complexity based on what I am using for my algorithm purpose? So if he says output is also counted, then the space complexity becomes O of n, because if you imagine, right, a tree with three nodes and all of them are right nodes, then in worst case you will have a list of n nodes, uh, right? So depends. So yeah, now after doing this, I'm going to start the code. Um, so yeah, for BFS, it's it's easy to write iterative code, and I'm going to do that for this. If if in trees, if you have to do DFS search, then I prefer to write it in a recursive way. But for BFS, like level by level, it's better to write um, iterative solution. Okay, so the edge case is taken care of. If not root return empty, then what I'm going to do is I'm going to have a queue which is going to have a single node root, right? And then I need a result which is going to be a list. And now while queue is not empty, so this is shortcut in Python. So while queue is present, that is queue is not empty, what I'm going to do is I'm going to take out the uh, yeah, I'm going to have a previous value. Previous is equal to, let's say, minus, or let's say 0. And I'm going, so what I have done here is, first level is always going to be a root, right? So I have added that root and I'm starting a while loop on that. So while queue is not empty, I have had a temporary variable. Let's say temp. Let's not call it previous, a temporary variable. And for underscore or I in range length of queue, what this means is whatever the values are in the queue right now, right? So take a snapshot of queue's length. So initially it's going to be 1. So iterate for at least one time and do take a node, right? Uh, q dot pop left. So remove the first element from the queue and add that, update the temporary variable value to node dot val, which is this. Okay. Now we are going through this level currently. So now the temporary variable has value 1. Now what is remaining is for this node, if there is a left child or right child, add it in the queue, and that will not iterate in this for loop. It will be added for the next iteration, which will be the next complete level. So yeah, if node dot left, q dot append node dot left, if node dot right, q dot append node dot right, and now this is complete. Let's say you are on this level, and you pop this element, you added left right. Okay, then you pop the second time, you added this and this. Let's assume there are elements. So once that is done, you have popped this element, and this last element in that level will be in the temp. So we are only saving the value of that. So what we do is, once this previous level is done, we can add to the result the value of temp, and then I think that's it. Once the queue is empty, you didn't add anything, and the last element in the queue would be the right element in that level. So return result. So yeah, I think this should work. Ideally, in interview, you should go through your code and dry run some example. I'm not going to do that because I'm going to use this run method. If there are any bugs or something, it will be caught. Uh, let's see. Um, Yeah, pretty, pretty good. I have solved this like 4 times so far, so I knew this. Yeah, so pretty efficient and good to go. Thanks.